Hi, I'm going to be walking you through the photosynthesis light process. So here we have the sun right here, going in our sunlight energy, and it's going to go into our reactor centers, our photosystem 2 and photosystem 1. And our reactor centers are basically our chlorophyll. And so when that sunlight energy hits our reaction centers, we're going to have excited electrons, which will bounce down our electron transport chain. So we have electrons here in photosystem 2 as well as photosystem 1. So we have electrons here as well. And so once these are all excited electrons, photosystem 1 electrons will tend to leave the thylakoid membrane and bounce out the membrane into, we have 2 electrons right here, plus a hydrogen ion, which would give us, we went from NADP to NADPH, right? And so here we have NADPH with our 2 electrons. And so now that we've lost 2 electrons in photosystem 1, this reaction center is feeling unstable and reactive. So what we will do here is photosystem 2 reaction center will donate its electrons to photosystem 1. And now photosystem 2 is actually feeling reactive and unstable. And so what we will do here is we have our water molecule. And so by splitting H2O, we're going to have 2 hydrogen ions on the outside, which is our thylakoid space, plus a single oxygen atom. And then when we break that, we are going to get, of course, our electron, so our energy going to photosystem 2 right here. And so here we have more energy, our excited electrons. These excited electrons are actually going to create a pump over here from our stroma to our thylakoid space. So now we have hydrogen ions going all the way, there's a pump, there's like the electrons over here acting as a pump to take down the hydrogen ions all the way down to the thylakoid space. And what was once an acetonic solution right here between these two, the thylakoid space and stroma, we now have a hypertonic solution over here with the thylakoid space, and then we have a hypotonic solution in the stroma. And there are 3 reasons to why this is happening. We have the pumping of the hydrogen ions right here with the excited electrons due to that. And then we have our forming of NADPH because we have a hydrogen going over here. And then we also have the splitting of our water molecule over here. And so we are getting 2 more hydrogen ions right here. So now with this hypertonic solution over here, we're going to want to go from high concentration to low concentration. So now we have the hydrogen ions here are going to go all the way here to ATP synthase, which is going to happen through facilitated diffusion because we do have a protein here. And with facilitated diffusion, we're going to have the hydrogen ions go through, and then that's going to cause a spinning motion, a circular spinning motion that will take ADP plus a phosphate and turn it into ATP with that energy. And so we're going to go through this process about 12 times to give us a total of 18 ATP and 12 NADPH. And then what we started with 12 water molecules, we're going to go to about 6 oxygen molecules. And that goes from the 1/2 of a oxygen molecule over here. So that's how we have that.